Welcome to solverfy.
So now we'll work on problem 110 from chapter 17. In this problem, we're asked to write the net ionic equation for the reaction that occurs when a solution of hydrochloric acid is mixed with a solution of sodium formate. So here, we're just writing the net ionic equation, so only the reactants that actually play a role in the reaction. So the proton from hydrochloric acid will play a role, as well as the formate ion from sodium formate. The chlorine and sodium ions are just there to neutralize the charge, but they do not take place in the they do not participate in the reaction. So this reaction will transform the formate into formic acid, CH2O2. So that's the net ionic equation for this reaction. In part B, we're asked to give the equilibrium constant for this reaction. So we don't have any values, but we can draw in what should be there. So it's CH2O2, the concentration of product over concentration of reactant. That's our expression for equilibrium constant. And then in part C, we're asked to calculate the equilibrium concentration of sodium, chlorine, hydrogen, formate, and formic acid when 50 milliliters of 0.15 molar HCl is mixed with 50 milliliters of 0.15 molar NaCHO2. So first, we can calculate the moles of each of the reactants that we're putting into this mixture. So moles of HCl is equal to 0.15 molar times 0.05 liters, and that gives a value of 0.0075 moles. And because the values for sodium formate are exactly the same, this also equals the moles of NaCHO2. So right away, because sodium and chlorine are not participating in this reaction, we can calculate their concentrations first because that will not change based on the reactivity. So the concentration of sodium is equal to the concentration of chlorine because these two species here are present in the same amount. And that concentration will be equal to the amount of moles that's put in at the beginning divided by the total volume, which is now 100 milliliters or 0.1 liters. And this gives a value of 0.075 molar. So that's the concentration value for sodium and chlorine. We can look at now the acid conjugate base and the proton concentration. So for that, we can draw an ice table. So we have CH2O2 reacting with to form. So the concentration of HCl and formate are the same. So HCl will react completely to completely use up formate, which means we only have formic acid left. So we have 0.15 moles or molarity. So we do 0.0075 moles of formate divided by 0.1, and we get a value of 0.075 for the concentration of formate as our initial. And then we have our conjugate base, CHO2 minus plus our proton, or H3O plus, either way. So we don't have any initial of this because the HCl has perfectly neutralized the formate. So we take away X and add X, and we get 0.075 minus X, X, and X. So our Ka here is equal to 1.8 times 10 to the minus 4. And that's equal to X squared over 0.075 minus X. So we can simplify by eliminating the negative X, and we can solve for X by multiplying by 0.075. And then taking the square root of the answer to give a value of 3.67 times 10 to the minus 3 molar. So this here is, let's write in red, the concentration of CHO2 minus is equal to the concentration of hydrogen plus, which is now, as we calculated, 3.67 times 10 to the minus 3 molar. And the last thing that we have to calculate is the concentration of formic acid, CH2O2. Now we know that we started after the reaction with HCl, we had 0.075. So all we have to do is subtract 0.075 subtract X from 0.075, as is described here in our equilibrium concentration, and the value that we get is 0.071 molar. So those are our 5 values for concentrations.